I don't have compliance reasons that says it has to be in London, so by all means, let's put it in America. Then I can choose the zone that I want to deploy my resource into. Remember, the virtual machines, they have to exist somewhere on physical hardware, and that physical hardware is held in the zones in the data centers, so I can choose the one that I want. I'm not fussed, so it can go with any. I then get to choose the configuration of my resource. Now it will default to an E2, which is a nice balanced kind of everyday. It's really good for web servers. It's not pushing the boundaries of performance. It's a very, very general purpose. I can then choose, do I want a teeny tiny one, only 1 gig of memory? Or do I want to go for really high memory, 128 gig of memory, or 32 gig of memory and 32 vCPUs? What do I want? These are all the pre-configured values, and there are a few of them. Based on the family, essentially, that you are working with. General purpose is looking for that nice balance. Compute optimized is obviously going to prioritize having vCPUs. Memory optimized is going to lean into a lovely, huge in-memory database here with 32,000 gig of RAM and 1,920 vCPUs. I don't think it's even going to show me a price for this one. No. This is that full example of walking into a shop and going, oh, I can't see prices anywhere. Can you tell me how much it is? And them going, if you've got to ask, it's too expensive for you. That's how I always feel when I see this. I don't earn enough. So have a little explore, have a little look at how much these might cost, but don't try and create one, especially in a lab environment, because your lab will get pulled. But storage optimized, we're leaning more towards a larger storage solution. And then if we're doing something with slightly more accelerated compute, where we need stronger and more powerful GPUs rather than CPUs, we can choose that one. We're not doing any of that. Let's go back to general purpose. Now I can choose these pre-configured types, or I can go to custom. And custom's fun because you get sliders. You don't just have to, you can type it in. Who wants to type when you can go wee and just set the exact amount of CPUs and RAM that you want to have? Now, I can specify I want 32 and only 16 gig of memory. That is totally fine. You'll notice that it changed 2 vCPUs to 1 gig of memory. There is a tie-in. You need to have at least this sort of balance. But you can specify exactly what you want, however much, and you can see how much that's going to cost you. It does also break down, if I make the screen just a little bit smaller, it breaks down what are the costs of the resources, what's the cost of the storage, and then if you are taking any particular logs, what are the likely costs for those. So it is very clear exactly what is being charged for which part of the service. I'm not going to have that giant type, but let's go to a nice small E2 micro. I only want to spend $6 this month. So there's a lot of ways that you can control the configuration of these resources. Not going to go into any of those. But then I can choose the operating system that I want. It defaults to a Linux. If you want a different one, you just click into change. You can choose the operating system type and then the version that you want. It will keep a couple of older operating system versions, but obviously moving towards a newer one is usually better from a security perspective. You can also upsize your storage. 10 gig is going to be the standard, but you can make it much bigger if you like. You can specify the encryption keys that you want to use. Remember, your data is encrypted by default. There isn't an option for no encryption, but you can choose the Google managed keys, your customer supplied keys, or a key management service key that you have a bit more control over. You can be very, very specific. Data protection, you can choose as and when you're taking snapshots, backups of your system. Networking. This is where you tie in your virtual machine with your VPC. We'd already chosen the zone we want to deploy into, that's fine. But this is where we can choose the actual VPC. Which network do I want to use? I've only got one. It's the default one that's given as standard when you create an account. That's fine. If I had more, I could choose the specific VPC that I want. You also get to choose kind of default firewall rules. Do I want this virtual machine to be internet connected? Yes. Do I want to allow HTTP and HTTPS traffic? Maybe. Those are the main things that we'll look at here, and I'll talk about some of the others in a bit. I'm just going to create that virtual machine nice and easy. It should have both an internal and an external IP address. And it will automatically have a button that will allow me to connect via SSH, a remote admin connection. We'll leave that for a moment and we'll come back once it's created. It'll only take about another 30 seconds or so. But it's very, very flexible. If you don't want that much control over the configuration, or you have certain software that you want automatically deployed onto these instances, you can use the cloud marketplace, which we just saw in a previous lab, as a way to deploy bundled infrastructure and software. You can also create your own images. If you have a specific image that you want to create, essentially, if you want to create use a standard virtual machine to start with, then install some software and then create an image, you can create that to use internally as part of your company in order to deploy the same configuration again and again. Let's just see before we move on to pricing. Yes, there we go. It's up and running. I have my internal IP, that's for communication inside my network. I've got my external IP, and then this SSH button will automatically allow me to connect to my virtual machine in this little browser window so that I can perform administrative commands on my virtual machine. So really, really easy to interact with. From a pricing perspective, I mentioned those sustained use discounts before. If you are running your virtual machine for at least 25% of the month, you start becoming eligible for an automatically applied discount. Every minute that your machine is running after that initial 25% of the month, you will then be eligible for this discount. And that discount, it grows for the first 25%, or after the first 25% of the month. You then get, I think it's a 10% discount for the first week, and then 20% discount, and then finally up to a 30% discount on the run time. So this is not something you need to apply for. It's automatically set up and run on your account. If, however, you know that you need X amount of CPU and RAM for 24/7 for a year, that's where your committed use discounts come in. If you guarantee to use X amount of CPU and RAM, or at least to pay for X amount of CPU and RAM for a year or for 3 years, you will get a discount up to 57%. It's 25% of the time for up to a 30% discount. The committed use discounts 1 or 3 years for up to a 57% discount on the on-demand price. And then we also have something called preemptible or spot VMs. So I thought we had another slide on that one, which is why I skipped ahead, but we don't. The preemptible or spot VMs are temporary short-term compute, essentially pulled from the spare capacity, essentially. Spot VMs are the newer iterations of preemptibles. You're probably just going to lean towards spot VMs now. Spot VMs, there is no maximum runtime. You can run them for as long as you like. However, Google can snatch them back within 30 seconds. They can give you 30 seconds notice and go, I need that compute back. Yoink. So only use spot VMs for fault-tolerant workloads, for workloads that can be interrupted. And that is a really big phrase, especially when it comes to exams. Spot VMs, interruptible workloads. That is keyword when it comes to that particular type of question. They're very, very good because you can have up to a 90% discount on the on-demand price for virtual machines. You can have a much larger amount of CPU and RAM. However, fault-tolerant workloads only. When it comes to the pricing, it is per second after that first minute, obviously, unless you've gone for the unless you've gone for the committed use discounts. But you pay for the CPU and RAM separately, and you pay for the storage separately. Okay, so it's a really easy way to scale. Because you are paying for the CPU and RAM separately, it is easier to add and remove resources without having to have like a whole new virtual machine. Just add some CPU in, add some RAM in, which also helps with that sustained use discount. Because if you start off, let's say we start the month with 4 vCPUs and let's say 10 gig of RAM. We run that for a full week for 25% of the month. We now have 4 CPUs and 10 gig of RAM that are eligible for a sustained use discount. For a week, we get that discount, and then we think we actually need to make our virtual machine a bit bigger. So we add in another 2 vCPUs and another 2 gig of RAM. The pink ones are still eligible for that sustained use discount, and they will still be getting that sustained use discount. The green ones, not yet eligible. They haven't run for long enough. However, they are all within the same virtual machine. So by paying for them separately, like this, rather than paying by machine type, you benefit a lot from those sustained use discounts and from the scalability of the system. So that's why that sort of payment system is fabulous. When it comes to our virtual machines, we can scale in 2 ways. We can either scale vertically, add more memory and CPU in. That's just what I was drawing with those squares. We added more memory and CPU into a single machine. What we are more likely to see in the cloud is horizontal scaling, adding more smaller computers together into a pool of systems. The reason being, we don't have a single point of failure. If we just make one really big virtual machine, it's great for very memory intensive systems where the data all needs to be in one place. However, we have a single point of failure. This goes down, our system's offline. With a horizontally scaled system, if this one goes offline, no biggie, system's still up and running. It's totally fine. Both ways are valid to scale depending on your use case. We're likely to see horizontal a little bit more just because it is easier to make your systems fault tolerant. But the scalability can be done automatically using managed instance groups, or we can manually scale by adding and removing resources as required. If you are interested in the specifics about the machine types, there is a documentation, compute/doc/machine types. Inside Google Cloud, there's plenty of documentation there just around the virtual machines and sort of the tutorial side of things as well. Alrighty, that's our virtual machines. Popping back to our networks. The great things about the VPCs is that you don't have to manage or maintain a router at all. That is built in as part of the VPC. We do not need to control that. We can set certain routes if we wish. We can define the routes inside our networks. If I head across to the VPCs, and we'll just have a look at my default network for the moment. Within my default network, I have the general overview. Subnets, because this is a default VPC and is one that's created for me when I set up my account, and because my VPCs are global, I should have, I think, 42 subnets. Let's scroll to the bottom and see how many I've got. 41, that's fine. It's maybe not updated with the most recent region, but every available region should have a subnet created for it automatically. There are two types of Google networks. There are auto networks and custom networks. If you've chosen an auto network, it will create a subnet for you in every available Google region. And when a new Google region comes online, it should automatically add in a new subnet within that region so that you maintain global spaces, if you will. This is created automatically for me. I have a list of my firewalls, pretty standard ones: allow SSH, HTTP, HTTPS, internal traffic, which means all of my subnets across the world can communicate with each other internally inside this network. Very, very easy. We've got the routes. Now, because there's loads of routes, there's 41 subnets, and every subnet can communicate with every other subnet. So it doesn't just list them. What you need to do is just pick the region that you're interested in. Let's go with Toronto and click View. I've got 42 routes. I've only got 41 subnets. Why have I got 42 routes? One of them is to the internet. Got my default internet gateway. You do not have to create the internet gateway. You do not have to specify the route to the internet gateway. That is handled by the Google network itself. The firewall rules are what is going to specify which traffic can go in and out to your resources. Okay. So it's really easy from a networking perspective. It sorts it all out for you, essentially. These firewall rules, you can add a new one very easily. Just pop in a name, specify the VPC that you want this network to apply to. I've only got the one, so I'm going to stick with default. Is it to protect from incoming or outgoing traffic? Am I making a rule that is an allow or a deny rule? What's the action? Then I get to choose. Does this firewall rule apply to every single instance and virtual machine inside my VPC, regardless of subnet? Every single resource? Or does it only activate, if you will, if a certain service account is trying to interact with that data? Or the most likely one, target tags. This firewall rule is only going to be applied to virtual machines with the tag demo, which means I can be really specific. Let's just stick with internet traffic from port 443. And this particular firewall rule will now only be applied to virtual machines that have the demo tag attached to them. None of my virtual machines have that tag on them. So this firewall rule won't do anything. But if I were to go to compute engine. And I'm going to, let's just create a new one. Firewall show. Everything else can just stay the same. I'm going to go into the networking section. And here I have a section called network tags. I'm going to add in that demo tag and create this virtual machine. Once that is up and running, it will then be subject to that firewall rule that I have set, and only that particular virtual machine within this network. That's the only one currently that firewall will relate to. But I could create hundreds more virtual machines that all have that demo tag, and they would all be subject to that particular firewall rule. It's a really easy way to manage your firewalls by using those instance tags. Great for infrastructure as code systems as well, to make sure that they've got those specific tags assigned to them. So with the VPCs, you don't need to manage a router. You don't need to manage firewall rules. There are default firewall rules that will be set. You can obviously amend those. You can delete any of the firewall rules to restrict access. You have control over them, but you don't have to if you don't wish. The tags for the instances are really, really useful. Okay. If you have multiple VPCs that you want to communicate with each other, then you... Running over, am I? No, not yet. No, good. Still got time. If you have multiple VPCs that you need to communicate with each other, you can use VPC peering. VPC peering, as with other cloud providers, is a one-to-one solution. Okay. VPC peering can get your VPCs to communicate with each other. However, if you have multiple VPCs that need to communicate with each other, it can get a little bit messy controlling all of those connections. It is a one-to-one and it's non-transitive. If you have multiple projects that all need to access the same services, maybe an Active Directory, maybe a security system, a better choice than VPC peering is to use a shared VPC. So hosting those services in one VPC and allowing multiple projects, access to that shared environment. So this is a way that you have kind of a central control over the IAM for multiple projects and multiple VPCs, and get them to access the same services that they require. So there are different ways to get them to communicate with each other. Got an hour left, right. Those are our networks. Those are our virtual machines. In the final lab that I do before we finish today, I'm going to create a network and I'm going to create some virtual machines. So you will get to see that again. Load balancing. If we are using horizontal scaling and we have, let's say, 100 virtual machines all offering the same web server, how do we make sure that our customers are reaching the relevant server without having to let every single one of our customers know the IP address of every single one of our resources? Much easier to just whack them behind a load balancer. Load balancing, a really easy way to distribute traffic through a single entry point to multiple backends. Google has a large number of load balancer types. Their load balancing is fully distributed, software defined, so you don't have to worry about maintaining the physical hardware. It's the software defined in the Andromeda networking stack. The load balancers work in front of HTTP and HTTPS traffic, TCP, SSL, and UDP. Depending on the type of traffic, that will depend on the type of load balancer that you want to use. Now, because Google's VPC is a global resource, we have a couple of types of load balancers. We have some of them that are regional, that just work within a subnet or within a couple of subnets within a region. There are others that are global load balancers. So if you have resources in Tokyo and in London, and you want to split the traffic between them, you can use a global load balancer to do that. Because it's software defined, you don't have to worry about pre-warming any load balancing for traffic spikes. It will just handle those and absorb those very, very easily. Like I said, there's quite a lot of load balancers in Google. We've got from a layer 7 perspective, we've got our application load balancer. External or internal, depending on the type of traffic, you might only need a load balancer for your internal communications. Totally fine. You might need it for customers around the world. That's often what we're using our load balancers for. Then you also get to make the choice. If it's an external one, is it a global system or is it just regional? If we're using internal load balancers, is it regional or is it cross-regional? Not referred to as global at that point, just cross-regional. With our application load balancers, they are using a proxy. So, it will be terminating your SSL connection at the proxy and then directing on to the relevant backend service. Something that might crop up in exam questions. The application load balancer is the only one that does path, also referred to as content-based routing. Based on the path in your URL. Google.com/forums would be sent to a certain set of backend services, and Google.com/users would be sent to a different set of resources. The application load balancer is the only one that does path-based or content-based routing, depending on the phrasing that you see. The network load balancers, working at layer 4, they are built for exceptionally fast, exceptionally high scale levels of connections. We're thinking thousands of connections per second. There are a couple of types, proxy and pass-through. Again, we get to choose, is it external, internal, is it global, is it regional? I'm not going to run through each of those. But as it says, several load balancing options, lots of choices, depending on the type of traffic that you are working with. In phase 2, you'll probably look into those in a bit more detail. At this point, just need to be aware of them. So cloud load balancing leads us on to our DNS system. Cloud DNS, the domain name system, essentially it is an internet-based phone book. This IP address leads to this web address. It's linking IP addresses to certain web addresses. Now, 8888 is the Google DNS address, basically. You don't have to remember 8888. You might do, you don't have to. But when it comes to DNS systems, essentially, we are just linking together IP addresses with human readable web names. I can't remember IP addresses of stuff, but I can remember argos.co.uk or google.com, for instance. I don't know what the IP addresses are going to be, but I don't have to. Just type in my lovely user-friendly web address, and then the DNS system does the rest. It goes, oh, actually, you need to go here. Like I can't remember any of my friends' phone numbers anymore. I used to know all of my friends' phone numbers. Now I just grab my phone and type in the name of the person I'm looking for, and my phone does the rest. Much easier. Well, it does hurt my brain slightly. But Cloud DNS is a managed DNS service running on exactly the same infrastructure as Google, the web servers, Google, the search engine. It is, I think, maybe the only service in the world from any company that has 100% SLA. They're so confident in it, it's never going to go down. Cloud DNS, 100% SLA. No other company in the world never really offers 100% SLA, just in case. Always got to have that wiggle room. But they are so confident in the caching, in the networking abilities, that it has 100% SLA. It's extremely low latency because there are caches around the world. It's a very cost-effective way to make your services available to your users. You can manage millions of DNS zones and records within the console, within the API, or within the CLI. Whichever domains you are managing, Cloud DNS can handle them for you. Tied in with our DNS systems and with our networks in general is our CDN, the Content Delivery Network. And again, these are the actual service names. Cloud Load Balancing is the name of the service. Cloud DNS is the name of the service. Cloud CDN is the name of the service. They've not gone for fancy names. They've very much named it what it does. Really, really useful. So you can figure out, you don't have to wade through murky namings of services. So the Content Delivery Network, the CDN, is a way to cache your content and deliver your content to your users around the world. The benefit of this means that your data, your content, can be stored closer to the end users, reducing the latency. There are over 200, I believe we saw in the locations slide earlier. Yeah, 202 edge locations, caching locations, more than that, around the world to cache your data. The great thing about Cloud CDN is it's a way for companies to save a bit of money, because every request to the origin, if your customers the world over are going to, let's say it's in a storage bucket, if your customers the world over are going to the storage bucket to get the same video file, let's say, if 1,000 of them want to watch this video, you are paying 1,000 request fees as the owner of that item. Whereas if you're using Cloud CDN, you would pay one request fee, then it's cached in a cache closer to the users, and then the rest of the users are requesting it from the cache, which means you're no longer paying those origin request fees. Great way to save money. It's also a great way for your users to have much lower latency. They no longer have to travel from Dusseldorf to Sao Paulo to fetch the data, because it's stored in a cache in Germany, much, much closer to where they are. It's also really easy to turn on. You literally just tick a box. Done. Super easy. Very, very straightforward to utilize. That brings us on to our final theory bit of the day before we do a quick quiz and then a lab. I know we've covered a lot today and it has been going fast. Remember, you have access to these slide decks. You are able to review this material and the labs will be enabled after the class today. So one more bit of theory and then we get a little bit of a practical, and then you can go away and have a look at the slides if you want to recap anything today as well. I told you earlier on that Google is really big on open source, on open vendor, on open connect. And a big part of that is the way that it allows VPC networks to communicate with various other systems. Now, obviously, if you have your own corporate environment, you are going to probably want some sort of hybrid connection. Your on-premise with your cloud-based environment so that you can communicate over a private connection. There are a couple of ways to do that. We've got Cloud VPN, standard VPN. We're going to talk about these in more detail over the next few slides. Then we've got some other groupings. We've got direct and carrier peering. Then dedicated interconnect and partner interconnect, and then the newest, which does sort of belong here, but it's the newest one, cross-cloud interconnect. Okay, so that's the groupings that we're going to have a little talk through. So we'll start with Cloud VPN. Pretty standard, a VPN, a virtual private network, giving yourself an encrypted tunnel between location A and location B. With Cloud VPN, this is a very quick way to get up and running and to have a hybrid connection between, let's just take your corporate office as an example. From your corporate office into your Google Cloud account, you can set up a VPN in minutes. It is creating this encrypted tunnel. Data will be encrypted as it's sent across it. However, it does run across public infrastructure. You are still using the internet cables, but you have an encrypted bubble, essentially, that your data is being sent across. Cloud VPN has a dual connection. It's basically a high availability connection into your Google Cloud account, and it uses BGP, the Border Gateway Protocol, in order to dynamically connect to make sure that there's no sort of bottlenecks on the line as it's going through. It is not always the best option because of security concerns or bandwidth reliability. I believe the available throughput is 1.5 gigabits per second. I might be wrong on the numbers. Pretty certain it's around there, but it is not a huge amount of throughput for vast companies. Also, if you have a compliance requirement that says your data can never, ever, 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 ever travel over the public internet, even if it's encrypted, then Cloud VPN is not going to be for you. The benefit of Cloud VPN, really quick to set up, couple minutes, bish bash bosh. I'm just going to reorder these slides slightly and hop onto this one. Because if Cloud VPN is not secure enough for you, or if it's not enough throughput for you, what you might want instead is to use dedicated interconnect. This is a hardwired connection from your premises into Google Cloud. Dedicated interconnect is essentially direct connect if you're coming from an AWS background. I'm not sure what it's called on Azure. Sorry, I'm not up to date on the Azure terminology, but it is a hardwired connection, which means you can have an extremely large throughput, 100 gigabytes. You can bundle them together and have a few more than that, gigabits per second. Exceptionally fast. However, because it's a physical cable, it's going to take a while, like 3 to 6 months to put into place, probably. Because you got to get in touch with the council, you got to get in touch with the borough, you got to get in touch with a whole bunch of people, dig up some pavements, lay some cable. It's going to take a while. It is not a quick and easy solution. Once that is in place, you're going to want to make sure you're using it enough to justify the cost. But if you are a company that has compliance requirements that says your data can never travel over the public internet, or if you have too much data or you require a larger amount of throughput than a VPN can handle, dedicated interconnect is going to be the way to go. If your data has to be encrypted, you can run a VPN on top of your dedicated interconnect in order to encrypt it. That is totally fine. Because it's a dedicated cable, it will not be encrypted by default unless you choose to set something up to encrypt it on top of that line. So dedicated interconnect, great for huge amounts of data and high throughput. Does take a little bit longer to put into place. And dedicated interconnect is about connecting your private VPC spaces, your private IP addresses from on-premise into your private VPC space and private resources in the Google Cloud environment. Because this is a physical cable, you need to make sure that you are near to a Google co-location facility. You might not be anywhere near one. in which case you can use partner interconnect. Exactly the same concept. You're just using a third-party intermediary. You might be too far away from Google, from the nearest Google co-location center, to make it worthwhile. So you just go via a third party. That third party has the dedicated interconnect, and then you just run a physical cable from your location to that partner. So that is an option. Again, the interconnects allow you to connect your private on-premise space with your private cloud-based space, your VPC. And the newest interconnect is cross-cloud interconnect, which just allows you to connect Google with AWS, or Google with Azure, or Google with Alibaba. I think Alibaba's also included. Maybe IBM as well. Extremely high bandwidth, dedicated connection between Google and those other cloud providers. The reason for this is a lot of people now are using a cross-cloud, a multi-cloud deployment, which makes sense. No one wants a single point of failure. Everyone wants to make sure that they have backups on backups on backups. If you're in Australia, there is a mandate, if you're in the Australian financial services, there is a mandate that you have to use a multi-cloud deployment. And obviously, if you're working in, let's say, AWS and Google, you don't really want to have to use public internet to transfer your data from one to the next. So using cross-cloud interconnect gives you that private dedicated connection. Comes in two sizes, 10 or 100 gigabits per second. Super fast. Now, I just reordered the slides slightly because I wanted to talk about VPNs and the interconnect services, because they connect your private IP address with your private IP address in the cloud. Those spaces, your private spaces. The other connection service that Google offers is called direct peering, or carrier peering if you're going through a third party. What this does is it allows you to connect to Google's public APIs. So the peering services, the direct peering, does not allow you to connect your VPC on-premise to your VPC in the cloud. What it does is it allows your on-premise resources to connect to Google's public APIs, like YouTube, like the workspace, like Google Docs, Google Sheets, like BigQuery, like cloud storage. Any Google Cloud service or Google Workspace service that exists outside of your VPC. Okay, that's an important thing to remember. Anything that's not using those private RFC 1918 IP addresses. So direct peering is about that public connection. Okay. It is utilizing a Google point of presence, not a Google co-location facility. Interconnects use co-location. Direct peering use points of presence. Direct peering is obviously you directly to Google. Carrier peering is just, again, going through a third party. If you are too far from the nearest Google point of presence, go via a third party, carrier peering. Carrier peering, because it's a peering connection, is allowing you to communicate with those Google public APIs. Okay, and that's an important distinction between peering and interconnect. Okay. You will be pleased to know we are at our final quiz of the day. We'll do 3 questions, and then I'll do the final lab, and then I will enable the labs, and you can all play with the labs. I know it's been a lot of information today. Well done, everyone, for sticking with it. Let's do a couple of quiz questions, and then we'll do a demo, and then we'll be done for today. Okie dokie. So, in Google Cloud VPCs, what scope do subnets have? Zonal, regional, global, or multi-regional? Okay, few mixed answers, but we're coming in strong with a lot of Bs? Absolutely. Subnets are a regional resource. VPCs are our global. Wonderful. Well done, everyone. What is the main reason customers choose preemptible or spot VMs? To improve performance, to reduce cost, to use custom machine types, to reduce cost on premium operating systems. So thinking about those premium or preemptible or spot VMs. Remember I said that we're more likely to see spot VMs nowadays. They are sort of the newer iteration. Brill, lots and lots of answers coming in. Nailing it, 100%, to reduce costs. Remember that those spot VMs are up to a 90% discount. But the really key word is an interruptible workload or a fault-tolerant workload. Those are the things that you should run on a spot VM, not something that needs consistency. Wonderful. Final question. For which of these interconnect options is a service level agreement available? Dedicated interconnect, standard network tier, direct peering, or carrier peering. Now, this is something that is on the slide, but I did not say out loud. Out of these interconnect options, which are we choosing? Fabulous. And there's also some keywords to look at on this one. Wonderful. You've all gone for dedicated interconnect. Nailed it. Because even if you weren't sure which one has an SLA, that is the keyword you're looking for. Direct peering and carrier peering, they are not interconnects, they are peering. Standard network tier, that's just about the sort of speed that your data is going to travel over the private network, essentially, which only leaves you with one, your dedicated interconnect. Wonderful. Well done, everyone. I know it's been a lot of information. There's just one more thing to do before the end of today, and that is getting started with VPC networking and Google Compute Engine. Now, it says it's a 40-minute lab. Don't worry, it's not going to take 40 minutes. We have 35 minutes left of today, and it shouldn't take that long. I am going to talk you through it. Some of these concepts we've already covered. So in the demos that I've done, we've already had a look at some of these. I'm going to click Start Lab just to let that sort of build itself. Within this lab, what you're going to do is have a little look at the default network. There is a default network created for you every time you have a project. What that gives you is a space to just start deploying services. But as a company, do not use the default networks that are given to you. As a company, you will obviously have some more restrictive requirements. As someone learning or as a hobbyist, by all means, use the default networks. They are built to best practices, but as a company, you will have much more stringent compliance requirements. So really hammer that home. You all know it anyway. I'm just covering my bases. So we're going to have a look at the default network. We're going to create a new network and then have a little look at how we can connect our virtual machines. So remember, time has started. If it finishes, we need to start again from the beginning, but that's not the end of the world. When we are opening the Cloud Console, right click, put it in a private or incognito browser. I do not want to be logged in as me when I get into my lab environment. Let's see, it's still going to ask me, welcome to this new account, blah, blah, blah. Yes, I understand, I accept. There'll be another little pop-up. I agree. That will happen all the time. Don't worry about that. Just agree and move on. And we can see I'm not signed in as me. I'm definitely signed in as student. So this has worked. I am not going to accidentally spin up resources in my own personal account. We want to make sure that that's not happening for you either, which is why we're using a private or incognito browser. Let's just get my pages sorted. Wonderful. Zoom into this one a little bit. So again, useful information given by the lab, login details, the project, and then the region and zone that I'm likely to need. Many more points available on this one, not just 10, 100. Ooh. In this lab, we're looking at the networking. We're looking at the virtual machines. So we're going to start off, again, task 1 just tells you how to log in, but you know how to do that. Task 0 on this one, not task 1. Task 1 is just looking at the network. You can get to it either from the hamburger menu or this navigation menu on the side to scroll down to VPC networks, or you can go to the search bar and type in networks or VPC, whatever you wish. I get rid of that sidebar. Let's get it out of the way. Rid of the tutorial as well. Give yourself a little bit more space. Feel free to just close any of the windows that are there that you don't need. There is a default network. Now, you might notice that in my personal account, I had 41 subnets. Here, there's only 24. The reason being the lab is slightly more locked down than my personal account, and it's limited the resources that it's created. That is totally fine. That is on purpose. We can have a little explore by clicking on the name of the network, and then we can have a look through the subnets, and we can see there's only 24. Fine, not an issue. The lab is going to want you to just expand the page slightly if you've got yours nice and small, to have a look at the IP ranges, and then head into, scooch along a little bit, to the roots. And again, you can pick any region. I think the lab might get you to have a look at the region assigned to you by the lab. Oh, if you see Quick Labs anywhere, that is what Google Skills used to be called before it was Skills Boost. So if you see Quick Labs, just mentally reword that to say Google Skills. My lab wants me to look at US East 4, but it doesn't matter. You can look at any region. Let's look at US East 4, North Virginia, have a little click on view, and I can see all of my routes to all of my other subnets and to the internet gateway. We did this in the initial demo. It is just about exploring and firewall rules. We can see the standard firewall rules, which will be allow ICMP, allow RDP, SSH, and internal. You want to have a look at these VPC firewall rules. These hierarchical ones, these are put in place by the lab, so don't worry about those. These VPC firewalls, these are the ones you're interested in, okay? We can then delete everything. Now, deleting the network is pretty easy. Deleting the rules, just pick yourself a little checkbox and click delete. And then you do the same with the VPC itself. Click the checkbox, click into the network, and there's a little bin, delete the network. In the lab, it is going to get you to delete the network, and then it's going to get you to try and create a virtual machine, which you won't be able to do because there isn't a network. You will get quite far through the creation default before the creation fails, okay, of the virtual machine. No, I will show you that a little bit, just so you know what to expect on that page. Let's go to Compute Engine. The deletion of a network does just take a moment or two. Still deleting, that's fine. I like opening my services in different tabs. That's not mandatory. You can absolutely open it in the same tab. I like to be able to flip back and forth. So that's why I open my new services when I'm searching for them in a new tab, just so I can easily navigate between them. Not mandatory at all, Personally, I find that helpful. Let's create an instance. It will allow you to go through all of these, but you'll notice that immediately I'm getting a warning here. You'll still be able to give it a name, choose the region, choose the machine type, change the operating system. But when you get to networking, at the moment, even though I can still choose the default network, all of the subnets have been deleted. There are no subnets here. That's going to let you know that actually this isn't going to work. And in a moment or two, this will disappear and then I will still get an error. So that's what the lab is going to get you to do. At this point, you should fail. You should not be able to create an instance. That is on purpose. Something else that I didn't show you earlier, there is this equivalent code button down the bottom, which shows you the CLI, the REST API, and the Terraform version. So this is a great way to have a little look at the programmatic way to create your resources as well. If you want to get a Terraform template using your specific configuration, just grab it from here. The command line, I mean, you don't always need all of this information. This is pretty detailed as a command, but it's really helpful. Not all of the Google services have this function, but it is interesting to explore. So have a little look at those equivalent codes when you're creating resources. Right. We've deleted our network. We've created ourselves, tried to create a virtual machine, which has failed because there is no network. So what we want to do is create a new network. We're going to click on the Create VPC. And remember I said there are a couple of types of networks, an auto mode and a custom mode. The auto mode network will give me a subnet in every available region. The custom will allow me to choose which regions and choose the IP ranges that I want to allocate. In this lab, it's going to get you to create an automatic network, an auto network. So we're just going to pop in a name. In this case, I'm going to call it My Network. We can choose custom or automatic. If I stick on custom, it's then going to give me the opportunity to name my subnets, to choose the region, to specify the type of IP addresses and the IP and possibly secondary IP range as well. We're not doing that. We are going to automatic. At which point I have no configuration control, but it tells me these are all of the subnets I am going to create for you. And it defaults to a /20 range, so 4096 IPs in every subnet. Remember, the lab is restricted, so you will only get a maximum of 24 subnets here. That's on purpose. Don't worry, you've not clicked anything wrong. We then get to choose the firewall rules that we want to apply. Scroll down a little further. There are default firewall rules using the name of your network, and then allow custom. It's basically going to allow all the internal communication. ICMP, RDP, SSH. Fine. Yes, I want to choose all of those. There are some default deny all ingress if it doesn't meet this criteria. And then an allow all egress, so your traffic can leave your network by default. You can choose not to have all of these. That is fine. But in the lab, we do want them all. And that's all we're really going to do. We're then just going to create. Again, we can see the equivalent command line, the equivalent REST. I skipped away from it. It will take just a moment or two to create that network. Once that network is created, the lab is going to ask you to just go and have a look at the subnet ranges for US East 4 and Europe West 1. Those regions might be different in your lab. This is assigned when you click Start Lab. So your regions might be slightly different. Look, there we go. Once this is up and running, the reason it wants you to have a look at the IP address ranges for these two subnets is it's going to get you to create virtual machines in those two subnets, and it just wants you to check that the private IP address, the internal IP address assigned to those virtual machines, comes from the range. There we go. So my network, looking at my subnets, got what, US East 4 and Europe West 1. Europe West 1, my IP range is 10.132 and US East 4 is 10.182. So 182 and 132. I'm just picking the middle digit because it's easier than remembering the whole things. What I'm then going to do, you can copy and paste these as well to a notepad if that's easier for you, if you want to remember them. It is just to demonstrate that resources are created using the IP addresses from within this range. We're then going to create a couple of virtual machines. So I'm going to go to my compute engine service, refresh this page, or if I was coming automatically from the original create an instance page, I would click create instance. Give it a name, mynet US VM. And I want it to be in East 4B. So it's automatically defaulted to US East 4. Great. Going to choose zone B. And the machine type I want to be an E2 micro. So it's already E2, fantastic. Scroll down a little bit. I don't want a medium, I want it to be the smallest one possible. So I'm just going to make myself a micro, and that's it. I'm not going to change anything else. If I were to go to networking, I would see that my network is automatically selected, and the subnet will be automatically chosen East or from within that range. Yes, that's fine. And I'm just going to create my machine. Does then give it just a really long name. Not the end of the world. Is that because I forgot to delete the beginning of that? That's my bad. I copy and pasted and forgot to delete the automatically generated name. Never mind. We're going to also create a machine in Europe West with exactly the same configuration. But this time I'm going to remember to delete the text that I don't want to be there. You go away. There we go. In Europe West 1, D. There we go. Still going to be an E2 micro and create. Go. Wonder again. I would need to stop my instance in order to rename it, so I'm not going to do that now on this lab. It's not that important. Let's just see. So my instances are created. If I click on, did I successfully create a VPC network and a virtual machine instance? Yes, I did. This is a scenario where the name that the lab has given you is not vital to you getting your points. There are some labs where the names are vital to you getting the points. It doesn't like it if you choose a different name. So when it comes to the labs, it's often best practice to just copy and paste the name that it gives you, because sometimes the points are a little bit awkward. This one didn't matter, thank goodness, but just be mindful that if you think I've created everything correctly, why is it not giving me the points? It might be because of the name. That is something that is just worth checking. Now this lab, actually, that's all I need to do to get the points. But what we want to do to just make sure that we are confident with how our virtual machines are working, how the firewall rules apply to those virtual machines, we are going to check our connectivity by using the SSH terminals. So I am going to click on, which one am I going to do? My American instance, my US East. I'm going to click on that SSH button. And it is just going to create for me a little terminal that I can use to communicate with my virtual machines. Now, I don't like this font, personal choice. So I always go up to this little cog here, and then I change the font to monospace. Personally, I find that more readable. And I also change the size. My excuse is because I'm teaching you all and I want you to see. The real reason is my eyes just don't work properly. So I have to make the text that bit bigger. So you can edit this so that it's more comfortable for you to read and work with. What we are going to do is use a very simple ping. We're just going to do a 3-count ping to our internal address of our other virtual machine. Remember that these are both in the same network, so they are able to communicate privately internally because of our firewall rules and because of the settings that we have. Now, you can absolutely just copy this by clicking those 2 squares and then Control V, pasting it in. But you will need to then get rid of the curly brace or the arrow, then all of that text. So it might just be easier to type it in. And we are going to grab the internal IP address of our second virtual machine. Paste that in, and then try and ping it. Great, we are getting a response. Fantastic. Internally, these 2 different regions, resources in completely different regions around the world, can communicate with each other. We're going to do exactly the same thing, except with now the external IP address, which is 34.77.66.76. And they can communicate externally as well. Great. Connectivity, definitely working. Those firewall rules are allowing the traffic that we want to communicate. There's then a little question that I will let you answer in your own time. What we're then going to do is get rid of the ICMP, the Internet Control Message Protocol rule. We're going to delete that rule from our VPC networks. We need to go back to VPCs. I still had the tab open. This is why I like multiple tabs. It's easier that way. Going to go to my firewalls, and I am going to delete allow ICMP. Just going to click the little button next to it and delete. Just wait for notification that that's completed. The notification bell will have a little circle whilst it's still in action, and then you get a little pop-up saying success, that has done. Great. So now that is up and running, or that rather is no longer up and running, it's been deleted. What I'm going to do is I am going to rerun my previous command. For those of you who haven't used Linux before, you can just use the up arrow on your keyboard to bring back a previous command, basically cycle through the history of all your previous commands. I've only got 2, but So I'm going back to my internal address, the internal address of my other virtual machine. I press enter. I am still able to communicate. Fantastic. Great. If I try the external, it is hanging. Nothing is allowing that traffic to go through. The reason being, we still have our custom firewall rule that allows internal communication from our resources. But we've taken away that ICMP that allows external communication of this ping protocol from one machine to the next. So that's why the internal one's still working, but the external one is not. The firewall rules are doing their job. You can play around with this. You can ping a whole bunch of other stuff. It's also going to get you to delete other firewall rules and just see the effect. I'm not going to demo those because it's the same process. You just right up until the end when you basically lose access to this terminal window as well because you've gotten rid of SSH. Very straightforward from a conceptual perspective, but just knowing how to do it in the Google environment, especially if you're new to it, can just be something that you follow through on the instructions. Step by step, they're all there. And look at this, I've got 12 minutes left. That never happens. Usually I'm like gabbling towards the end. Thank you for sticking with me today. I know it's been a lot. I hope it's been really helpful so far. We have another session tomorrow from 9 till 1. Potentially slightly less bam, 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 bam tomorrow because we've covered those basic concepts this morning. Tomorrow we are going to look at storage, containers and applications in the cloud. We'll have a little chat about some of the things that we looked at today. There are 2 more labs tomorrow. Thank you for all your questions as well. I can see that loads of questions have come in, and thank you, support team. You've been absolutely brilliant all the way through this session. Thank you all for using the React buttons as well and getting involved in the quizzes. I am going to enable those labs as soon as we finish this session. So those first 2, remember, there's only 2 that are available today. The other 2 I will enable after tomorrow's session. Okay. Remember, you can do each lab up to 3 times, and you need to do at least 3 of the 4 before next week in order to qualify for the next stage of the program. Wonderful. Okie dokie. Thank you for being here again today. I hope you have a wonderful rest of your day. I hope you've enjoyed the session, and I will see you tomorrow morning. I am going to go back to bed because it's only 8:30. So I'm going to go and have a nap. Wonderful, wonderful, wonderful. I'm glad you enjoyed it. Fab, fab, fab. Just having a little look through a couple of the messages. Wonderful. Labs not mandatory to be completed today. No, you have a week. You've got 7 days to complete these, but I am going to enable them as soon as this finishes, just so then you can do them if you want. Wonderful. I'll see you all tomorrow. Have a lovely rest of your day. Roll, roll, roll. No, you don't have to do them 3 times, but you can. You have the scope to do them 3 times if you wish. You only have to do them once, and obviously get the points, complete the lab at least once on each one. Wonderful. See you in the morning. Have a lovely rest of your day. There's no recording, unfortunately, but in the Google Skills platform, you do have access to the lecture notes. So within the Google Skills platform, there's this second tab, lecture notes. That's all the slides, all the resources. There's no specific notification for lab completion, but remember that gold tab on the side here? You just want to make sure that you get all of the points. Do not end the lab until you got all the points here, and then you can cancel it. or end the lab at that point. No email required about activation of the labs. I'm literally going to activate. In fact, I'll do it while you're on the call. I'll carry on rattling and talking through. Bear with, caller, bear with, whilst I try and talk and press buttons at the same time. But I will activate them literally whilst you're on the call, so you can see me doing it and you know for a fact it has happened. So what I'm going to do, I'll even do it on screen. Ooh, I'm going to activate Cloud Marketplace and then activate VPC networking. Now, on your end, you should see green dots next to those first two, which means if you want to do the labs today, you absolutely can. If you don't have time today, don't panic, not a problem. You've got 7 days to do them. These bottom two will still be grayed out. Tomorrow, I will make them available. Fab, fab, fab. Great. Wonderful, wonderful. Yeah, great. You are able to see those first two that have been enabled. Fab, fab, fab. If you complete them today, does it count towards qualification for stage 2? Absolutely. You've come to this session. You've been, as long as you are signed in with your corporate email address and you have access to this classrooms section. Yeah, if you do them today, absolutely they count. Brill. Fab, I'm glad you enjoyed it. Alrighty.
Thank you, Hannah. Thank you so much. It was a pleasure.
Thank you for your help today.
You're welcome. No problem.
But will you be on tomorrow as well?
Sorry?
Will you be on this session tomorrow as well?
Not tomorrow. Tomorrow, we're gonna be someone else, but I'm afraid I have some other commitments. So yeah.
Fabulous. No worries. In that case, have a great rest of your week.
Yep. Thank you so much, Hannah, and wish you the same. Yeah. Have a nice one.
See you all tomorrow. Wonderful, wonderful, wonderful.
Yep. See you guys tomorrow. And yep, Hannah, we can end the session now.
Okay,
Thank you so much for your time.
Bye bye, everyone. See you tomorrow.